Hi there! For this video, we'll be discussing the remainder theorem. Along with this, we'll also be discussing the factor theorem since these two are kinda related. To do this, we'll start by illustrating an example. So let's have 3x squared plus x minus 5 divided by x minus 1. Suppose that we are tasked to find the remainder after dividing these two. Now the remainder theorem states that to get the remainder, we can simply first equate this one to 0. So we will have x minus 1 equals 0, which will give us x equals 1. After that, we will use this value to evaluate the dividend. So this will be step 2. So we'll have at x equals 1, we will have 3 times 1 squared plus 1 minus 5. Simplifying this, we'll have 3 times 1 squared is 1 plus 1 minus 5, which will give us 3 plus 1 minus 5. And when simplified, this will be negative 1. So the remainder, when we divide 3x squared plus x minus 5 by x minus 1, is simply negative 1. And so that is how we apply the remainder theorem. Let's have another example. Let's have x squared, let's use x cubed rather, plus x squared minus 10x plus 8 divided by x minus 2. Again, applying the same idea from a while ago, we'll have x minus 2 equals 0, which would give us x equals 2. So, at x equals 2, this one out here becomes 2 cubed plus 2 squared minus 10 times 2 plus 8. Simplifying, first, 2 cubed will be 8 plus 2 squared will be 4 minus 2 times 10 will be 20 plus 8. Simplifying this, you can observe that this will be equal to 0. So the remainder when we divide x cubed plus x squared minus 10x plus 8 by x minus 2 is 0. And from here, since the remainder is 0, what does that usually mean when we talk about real numbers? For instance, if we have, say, 2 and we have 2 divides 4, then we know that the remainder here is 0 since 4 is divisible by 2. We also know that this implies that 2 is a factor of 4. And the same idea applies in this one. Since the remainder here is 0, then we can say that x minus 2 is a factor of x cubed plus x squared minus 10x plus 8. And this idea is what we call the factor theorem. So the factor theorem states that if a polynomial is evaluated at x equals r, in this case x equals 2, and it results to 0, then x minus r, in this case x minus 2, is a factor of the given polynomial. Let's have one last example. Suppose that we have 8x cubed minus 4x squared minus 2x plus 1 divided by 2x minus 1. Now we will find, first, let's find the remainder, and afterwards we determine if 2x minus 1 is a factor of 8x cubed minus 4x squared minus 2x plus 1 or not. So first, by applying the remainder theorem, we first equate this to 0. This will be 2x minus 1 equals 0. Transfer the negative 1 out here. We will obtain 2x equals 1. Divide 1/2 in both sides. So the 2 here will cancel out, and we'll obtain x equals 1/2. So what we do next is we evaluate the dividend by x equals 1/2. So we'll have at x equals 1/2, 8 times 1/2 cubed minus 4 times 1/2 squared minus 2 times 1/2 plus 1. This will be equal to, note that 1/2 cubed will result into 1 over 8 minus 4 times 1/2 squared will result into 1 over 4 minus 2 times 1/2 will simply cancel out, so we'll obtain negative 1 and plus 1. Observe here that 8 here will cancel out, 4 here will cancel out, so this will be simply 1 minus 1 minus 1 plus 1, or simply 0. So we know that the remainder, when we divide 8x cubed minus 4x squared minus 2x plus 1 by 2x minus 1, the remainder is 0. So we have finally answered the first question. Next, we determine if 2x minus 1 is a factor of the given polynomial. Again, by the factor theorem, if after applying the remainder theorem and the result is 0, this implies that 2x minus 1, or the divisor, is a factor of the given polynomial, which is 8x cubed minus 4x squared minus 2x plus 1. So 2x minus 1 is a factor. So we check this. And so we have finally answered the two questions that we have for this problem. And so that is how we apply the remainder theorem and the factor theorem. The key is to simply evaluate the given polynomial by the value of x when we equate the divisor into 0. And also take note of these kinds of examples, since what we usually do is we simply take this one and use this to evaluate the given polynomial. But sometimes there is a coefficient of x, so we'll need to divide that like what we did here to obtain the true value or the real value of x. And so I hope you enjoyed this video and you've learned a lot from this one. Feel free to comment any comments, suggestions, recommendations that you would want to see in our future videos. And so that's it, and that is all for this video.